Now, in Algebra 1, you were probably taught that you can never ever take a square root of a negative number. And for the most part, that is true. And that was true in Algebra 1 because we typically stayed in the field of real numbers. We were interested in answers that belonged to the real number system. But as you get more advanced and more involved in mathematics, there will be lots of situations where you sort of have to take a square root of a negative number, and that's not a bad thing. We just need to be able to have mathematics behind taking square root of negative numbers to do algebra. Now, the mathematics that was created to address the issue of taking a square root of a negative number is what we call the complex number system. So let's start off with a few definitions, vocabulary, so on and so forth. Right? In the complex number system, we have something called the complex unit. And that basically is the square root of a negative 1. That's the simplest square root of a negative number you can think of. Well, mathematicians, we're going to define that by this number I here, or this letter I. And that's it. That's the big secret. That is how you handle square roots of a negative number. Long story short, anytime you take a square root of a negative number, you're just going to have an I in your answer. It doesn't really affect overall how you do mathematics, what the mathematics is, and what you can do with it. You'll find out that in this lesson, you're going to be doing sort of the same operations, the same strategies as you did with regular numbers, as you did with polynomials. So you'll find out that it's not a big deal really to work with complex numbers. What is a complex number? Let's go ahead and define that. The letter or the symbol that we typically use to denote complex numbers is Z. And Z is defined as A plus BI, right? That's it. A complex number is just a two-dimensional number that has two pieces. A is typically called the real component, and B is typically called the imaginary component. And other than that, it works the same way as any two-dimensional or binomial that you can think of. So let's think, what can we do with regular numbers? Well, we can perform arithmetic operations on them. Add, subtract, multiply, and divide. Let's break them down into each type. So, how to add or subtract complex numbers. The idea is to simply combine like terms. That's it. I mean, I wish I could make this even grandstanding, and I wish I could make this complicated, but it really isn't. To add and subtract complex numbers, you just combine like terms. For example, if I asked you to do 2 plus 5i plus 7 minus 2i, right? You just combine like terms. Here's the real part, and here are the imaginary terms. So you just go ahead and combine them. What's the yellows? 2 plus 7, that's 9. What's the pink? 5i plus negative 2i, that's 3i. Easy peasy. Okay. Works the same way with subtraction. 6 plus 3i minus 4 minus i. What I would suggest you do, however, with every single subtraction problem, go ahead and take the extra step and distribute the negative. So that gives us 6 plus 3i, distributing the negative, minus 4 plus i. Now we go ahead and combine like terms. So the yellows will be the real, the pinks will be the imaginary. So then just combine them. Yellow, 6 plus negative 4 is a 2. The pink, 3i plus i is a 4i. Easy peasy. So adding, subtracting, I'm not too worried about. I'm fairly confident that you guys have the ability to add and subtract complex numbers. When it comes to multiplying complex numbers, how to multiply complex numbers. What's the idea? The idea is just repeated distribution. Some of you guys like the term FOIL. I'm not a big fan of it, but if that helps you, think of FOIL. But that's the big secret of complex numbers. It's just repeated distribution. The same way you would multiply x's together will be the same way you would multiply i's together. Now let's take a look at an example here. Suppose I ask you to multiply 2 plus I times negative 5 plus 2i. So you just do regular repeated distribution. Let's distribute the 2. 2 times negative 5 is negative 10 equals 2 times 2i is a positive 4i. I times minus 5 is minus 5i. And I times 2i is 2i squared. Just like how x times x is x squared, I times I is I squared. And then you just go ahead and combine like terms. In this case, we only have like terms in the middle here. We have like terms here and a like term there. So we get negative 10 minus I plus 2i squared. Now, at this point, I sort of want to mention something. So this is sort of like as an aside. Remember how we defined I at the beginning. We said I was the square root of negative 1. Well, we have an I squared here. Well, what is I squared? Well, if we just put a square on both sides, remember what you learned in Algebra 1. A square and a square root, they sort of cancel each other out. So this guy here, the square and square root, they sort of cancel each other out. And that leaves us with I squared equals negative 1. So anytime you see an exponent on an I, you should be able to simplify him. In this case, I squared is negative 1. That's the substitution I'm going to make. Instead of 2i squared, it's going to be 2 times negative 1, which of course is negative 2. And then I have more like terms to combine. So my final answer is negative 12 minus I. That is the product of the original problem. So multiplying, so adding, subtracting, multiplying complex numbers, even though this I thing seems like a very new, hip, high-level math thing, it's basically just a mathematical object, and you just treat it like a regular variable. You add and subtract the same way, combine like terms, you multiply the same way, repeated distribution. You just have to remember that I squared is negative 1. Dividing is when things get a little bit interesting. Before we tackle dividing, I need to talk about a vocab word here. Vocab. The word conjugate. In math, the word conjugate is an identical binomial except the middle sign, positive or negative, is opposite. So let's remember a complex number. That's a plus bi. So a conjugate would be simply another complex number where the imaginary part is flipped. So for example, 2 minus 3i and 2 plus 3i. See how the middle symbols got flipped? Everything else is the same, but the middle symbol got flipped. I would say these two guys are conjugates. And it's only the middle guy that gets flipped. So if I had something like negative 1 plus 4i, well, his conjugate is negative 1 minus 4i. Only the middle guys got flipped. And it's only the middle sign that gets flipped. So if I had like 2, it is its own conjugate. Remember, for complex number, conjugate is just the imaginary part that got flipped. So if I just have a real number, it is its own conjugate. Likewise, if I had a pure imaginary number, say like 5i, his conjugate is negative 5i. So why am I spending time on this vocabulary word, the word conjugate? Conjugate of a complex number is the identical number except the imaginary part is flipped. Well, we're going to be doing conjugates for division for a special case. When it comes to dividing, you're going to have two possible types. Let's talk about type 1. A monomial in the denominator. If you have a monomial in the denominator, the strategy, just multiply the numerator and denominator by I. These are the simplest types. No thinking involved. If you're dividing two complex numbers and there's just a single piece in the denominator, just multiply the numerator and denominator by I. Let's do a quick example here. Let's say I wanted to do, 5 plus 2i divided by 4i, right? I don't care what's on top. All I care about is in the denominator. Notice there's only one piece, a monomial. So because there's a monomial in the denominator, the technique is just to multiply everything, top and bottom, by I. So let's go ahead and distribute. That gives us 5i. That gives us plus 2i squared. And then the denominator gives us 4i squared. Well, remember, I squared is simply negative 1. So that's 5i plus 2 times negative 1 over 4 times negative 1. And then do some math. That's negative 2 plus 5i over negative 4. Now, technically, that is the right answer, right? But sometimes, especially on homework, on quizzes and whatnot, they're gonna say put your answer in standard form, and standard form has the fraction split. So notice this is one giant fraction. I'm gonna rewrite this problem as this guy gets split, negative 2 over negative 4, plus this guy gets split, 5 over negative 4i. And then you just go ahead and simplify him. So this equals 1/2, and then a positive with a negative makes a negative, 5 over 4i. This is how you're going to see the answer on the practice. So the instructions will say standard form, and standard form is just splitting apart the fraction. So this type was the easiest. The second type just requires a little bit more work, but it's not hard conceptually, right? The other possibility is when you have a binomial in the denominator. And the strategy is to multiply the numerator and denominator by the conjugate of the denominator. So this is why I sort of talked about the vocab word conjugate. If there are two pieces in the denominator that you're dividing by, you have no choice. You got to multiply by the conjugate. Let's take a look at an example here. Suppose I wanted to divide 6 plus 4i over 2 plus I. So notice in the denominator, I have a binomial. So the idea is, since I have a binomial, I'm going to multiply top and bottom by the conjugate. Well, the conjugate of 2 plus I is 2 minus I. So then you go ahead and do repeated distribution, or FOIL, if that's what you want to call it. 6 times 2 is 12. 6 times minus I is minus 6i. 4i times 2 is positive 8i. 4i times a minus I is a minus 4i squared. And in the denominator, if you did the repeated distribution, that's going to be 4 minus 2i plus 2i minus I squared. And then you just combine like terms separate in the numerator and denominator. So you get a 12. These guys here combine to a positive 2i. And remember that I squared is negative 1. So I have a negative 4 with an I squared. Because I squared is negative 1, negative 4 times negative 1 is going to be a positive 4. In the denominator, these guys cancel out. And same issue over here. See, an I squared is a negative 1. So I have a minus I squared. That's a minus negative 1, or in other words, plus 1. So do some more combining. That gives us a 16 plus 2i over 5. Technically speaking, that is the right answer, but we want to write it in standard form. Standard form just has these two fractions split apart. So the best looking answer, the answer that you can see on the answer key, is 16 over 5 plus 2/5 I. So above all else, dividing will probably be the most tricky, but it isn't tricky at all. The strategy is very simple. It all depends on what you have. If you have a monomial denominator, just multiply the top and bottom by I. If you have a binomial denominator, just multiply top and bottom by the conjugate of the denominator. Hopefully by now you're feeling very comfortable working with I's. And again, it really doesn't change the math. In fact, it doesn't change what we did yesterday, which is solving equations. The only extra thing you have to remember now is anytime you take a square root of a negative number, just pull out the negative with an I. That's it, right? Suppose I had to take the square root of a negative, I don't know, 8. Well, anytime you take a square root of a negative number, just pull out that negative with an I. And then the radical becomes a positive, and you can simplify it using the tree like normal. Let's just go ahead and do a quick example here. Suppose I ask you to solve, I don't know, x squares minus 10x's plus 40 equals 0. Right. This looks like an example we did yesterday. The first thing I want to do is try factoring. But gosh darn it, try, it's not factorable. So if it's not factorable, you can use completing the square or the quadratic formula. Since the leading coefficient is 1 and this guy is even, I'm going to use completing the square because I think it's easiest. So I'm going to subtract the 40. I'm going to add my special number, which is half of this number squared, so that's 25. Do it to both sides. And then I can factor. So this guy's going to be x minus 5 squared. This is a negative, is that 15? Then I can take the square root of both sides. X minus 5 equals plus or minus. Notice, I'm taking a square root of a negative. So the only thing that changes is you need to pull out this negative, take that negative out with an I. Then the radical becomes positive as normal. That is the only difference between today's solving questions and yesterday's solving questions. And of course, you would then go ahead and add 5 to both sides. So that would be your final answer. So in today's practice, you're going to have some solving questions after you work a bit with imaginary numbers. Just remember, anytime you take a square root of a negative number, just pull out that negative to make it positive with an I. Then everything else is the same as yesterday. Give it a shot, go ahead and practice, and as always, please ask questions if you have any.